Hello everybody, this is Brian Taylor from my home office in Minneapolis. Hope everybody is doing well. This is my week 3 mini lecture. Hopefully you'll get a chance to review this and it corresponds with some of the assigned readings that both Dr. Weinstein and myself have assigned for you. Let's go ahead and get started with the functional correlates of age-related hearing loss. And that basic idea, which you see here on the screen, which is why is it that older adults often report speech understanding difficulties and other issues related to communication that exceed those reported by younger adults with similar degrees of hearing loss. In other words, patients that take two patients with identical audiograms and perhaps even the same word recognition scores in quiet, why does the 85-year-old patient why do they struggle much more than the 65-year-old patient? And that's kind of the basic idea of what we're going to get at today. So there's the why question. And there's a couple of different ways we can look at this. I call this the traditional view, which is looking at kind of a compartmentalized approach, which is each component of the auditory system or each landmark of the auditory system is aging. And that typically is termed presbycusis, and there's of course different kinds of presbycusis that you've learned about, and a good example, if you're looking for a reference that gets into that compartmentalized approach, is listed there on the screen. And in your reading I pulled something that was relatively recent, but it takes this more traditional view and looks at each one of these types of presbycusis. I don't know how you say that. Each type of presbycusis as they're categorized here on the screen. Of course, this is still important information. The point I want to make is this is kind of the traditional view where you're looking at each part of the auditory system kind of individually. But it should be noted that in the late 90s and in the early 2000s, among researchers, there was a shift in thinking. And they went from that kind of this modularized site of lesion view to a more systemic view of the auditory system, more holistic view of the auditory system. And today, the current thinking is shaped by this. We look at the entire auditory and cognitive system as kind of a continuum that involves aspects of working memory, speech comprehension, signal processing, perception, attention, and even higher level forms of thinking or cognition as part of one holistic system. And that's really shaped the way and the type of research that's been done over the last 10 to 15 years. For example, you look at some of the outstanding work that Catherine Pechora Fuller and her team have done up in Toronto, and you get an idea of how that shift in thinking has really impacted the type of research that's been done recently. And of course, as I've already mentioned, this is a more holistic view of the system being interconnected and that aging is occurring throughout that system. And the first place where this was really brought out into publications was by a group called the Berlin Group. And they had 4 explanations for this interconnectedness. Let's kind of go through those quickly, and hopefully you'll read a little bit about these in your assigned readings. The first explanation of interconnectedness is that, and this is called the common cause hypothesis, is that there's a decline across the board in the way the system operates, widespread neural degeneration. And if you look at this at the cellular level, and I think this may be something that Dr. Weinstein had you read, you can see the citation at the bottom, there's a host of factors going on that cause tissue destruction. Some of that is genetic, some of that is inflammation caused by habits that people have or exposure to certain substances. But of course, as we age, that would be one of those factors that cause hypoxia, inflammation, and eventually mitochondrial dysfunction. Another way to explain the interconnectedness between the ear and the brain would be to look at what's called the cognitive load hypothesis, which is how cognitive decline results in perceptual decline. And some of the work of Frank Lin and his group at Johns Hopkins really underscores this point. This slide is here to remind us that aging and microvascular diseases such as type 2 diabetes have an impact on hearing loss, and in hearing loss in their work and others has shown that that age-related hearing loss is independently associated with reduced social engagement, both physical and functioning changes in the brain, and of course increases in cognitive load, which means ultimately it's people that have a hearing loss have to work a lot more hard, have to work a lot more, it's a lot more challenging for them. They have to work harder. They have to allocate other cognitive resources to follow the conversation when they're compared to similar patients that might be 10 or 20 years younger. Another explanation for this interconnectedness between the brain and the ear is the deprivation hypothesis. Perceptual decline results in permanent cognitive decline. And some of you might be familiar with some of the work that Shlomo Silman did back in the late 80s and early 90s that looked at auditory deprivation and the effects that had on some of the higher level functions. And then finally, the information degradation hypothesis, which is basically starving the brain of information because the ear doesn't hear, isn't able to pick it up, that starves the brain of information. So this relationship between a limited signal or a degraded or a distorted signal has an impact on overall cognitive performance. So those are the four factors that have been studied rather extensively over the last decade and a half, and it's good as audiologists to know about this interconnectedness. This is a nice slide that I think really does a superb job of summarizing the relationship between ear and brain. We often hear the terms bottom-up and top-down processing, and it's really a combination of both of those things that makes listening and communicating for elderly patients more difficult than for patients that may have the same audiogram but be 10 or 20 years younger. Of course, we have more effortful listening. We also know that the ear-to-brain signal becomes degraded. When that signal is poor, it slows down and makes it more difficult for the person to process. And we can also look from the top down, brain to ear, know that a person's knowledge of language and their overall declining cognitive health has an impact on how they communicate. So I think this slide does a nice job of summarizing the complexity and the interconnectedness of the entire aging auditory system. And hopefully in your reading that will become more apparent. And of course, some of the real-world functional correlates, how does this matter in a typical audiology practice? We're dealing with patients as they age, the degraded auditory signal, the degraded audibility, the distorted signal become more apparent. And of course, we're working with patients that have poor memory and slower overall processing, and it becomes more of a challenge working with them when the entire interconnected system becomes affected. And then finally, I want you to think about how does hearing loss and some of these other functional correlates, how may that masquerade as dementia? There's lots of examples. I shouldn't say lots of examples. There's a few examples in the emerging literature that show that patients that have been diagnosed with one type of dementia or a various form of dementia may in fact have a hearing loss that makes it difficult to really ferret out the degree of cognitive difficulty. So there's a real interconnectedness here that we have to appreciate when we work clinically with these folks. So let's get right into the discussion points for next week. And these are some things that I want you to use to kind of help make sense of the literature so it's useful for you in clinical practice. So the first discussion point I want to address next week is when older and younger adults with similar audiometric results the typical results, threshold, speech recognition scores. When those patients are placed in the same challenging listening environment, and we'll just say it's moderate noise, reverberation, limited visual cues, and a few people talking, typical restaurant environment, I want you to we'll talk about and discuss how the use of bottom-up and top-down processing concepts can help explain why those patients are more likely to struggle. And then at the bottom there, I have a couple hints on how you might want to find that, get that information out. Now, another kind of a 1B here would be, the traditional approach explains only part of the difficulty, whereas the approach, the interconnectedness, top-down, bottom-up approach, I think does a better job maybe of explaining why those patients struggle. So I want you to kind of think that through as we discuss this on our chat next week, and also as you're reading those things. The discussion point number 2, go to PubMed and type in the following keywords: hearing aids, compression, and working memory, and find 4 abstracts. Look for names like Lunner, Lunner, and Souza at Northwestern. Those are some good ones. And read their abstracts and be prepared to discuss how their findings from the reading would impact the way you may program the compression parameters of a hearing aid, and how that may alter your counseling approach with patients that are more likely to have these auditory cognitive deficits. And then finally, discussion point number 3, be prepared in the next chat to talk about a patient that you may have seen recently in your clinic that had top-down, bottom-up issues. I forgot to upward on the slide there. And importantly, how did you address their situation? So that's some food for thought for the chat next week, and I look forward to leading that discussion when the time comes.